Hi guys! For today's video, our objectives are illustrate trapezoid and median of a trapezoid, 2. Solve real-life problems involving median of a trapezoid, and 3. Appreciate the importance of the concepts of trapezoid in solving problems. Consider yourself an engineer in charge of constructing a bridge, and the bridge will appear as shown. What do you see in the picture? You can see that a kind of metal cage is used to hold up the actual bridge. The cage has a slanted side, and we have the top and the bottom side, which is longer on one side than the other. Let's say the bridge has a 350 feet and we have 800 feet below or the bottom. And you would like to construct a real support beam where the yellow line is shown. The length of this support beam is unknown to you. What do you think the length of this support beam is? After learning this lesson for today, we can solve the measure of the support beam of our bridge. But before that, let's start our lesson through the definition of terms. Let's start a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Then we have the different types of a trapezoid. We have according to angles and according to sides. The first one is according to angles. We have the right trapezoid, two adjacent right angles, 90 degrees. We have obtuse trapezoid, two opposite angles are obtuse. We have greater than 90 degrees. And then acute trapezoid, wherein two adjacent angles are acute. We have less than 90 degrees. Then according to sides, we have the scalene trapezoids. No sides are equal. And then the isosceles trapezoids, two sides are equal. And then let us proceed to the parts of our trapezoid. So we have parallel sides are called the bases. We have trapezoid ABCD. Then we have the non-parallel sides are called the legs. And then the last one, we have a median of a trapezoid is the segment that joins the midpoints of the non-parallel sides or the legs. So again, we have the bases. In our given figure, the bases are line segment AD and line segment BC. Then we have the legs. In the figure, the legs are line segment AB and line segment BC. And of course, the median. The median is line segment EF, and then the midpoints are point E and point F. Now, let us continue to solve the length of our support beam on our imaginary bridge. The shape of that bridge is a trapezoid. As we all know that a trapezoid has all kinds of properties, but in this lesson, we will be learning about the median. The support beam is the median of a trapezoid, and you can see how it cut each leg in half. So, using theorem number 6, that the median of a trapezoid is parallel to its bases and each length is half the sum of the lengths of the bases. So, the formula is the median is equal to 1/2 quantity base of 1 plus base of 2. So, we will use this formula to solve the median of our bridge or the support beam. So, the median is equal to 1/2 quantity base of 1 plus base of 2. Then you have to substitute the 350 feet and then 800 feet. So we have median is equal to 350 plus 800. The total is 1,150. Then let us divide by 2 or get the half of 1,150, and that is 575 feet. And that is the median of our bridge, or the measure of the support beam. And now let us apply that theorem number 6 using these examples. So we have tone is a trapezoid. We have the median is RS. This is the median. Then for letter A, what are the bases? B, what are the legs? And then C, we will solve for RS. Then for D, find X. And then E, solve for EN. So let us continue. Using the figure for tone, trapezoid tone rather, the bases are, we have line segment TO and line segment NE or EN. The legs are the non-parallel sides. So in this figure, the legs are line segment TE and line segment ON. Then for letter C, our problem is if TO equals 18 and EN equals 24, find RS. So look for the figure. What is RS? Okay, very good. RS is a median. So we use median is equal to 1/2 quantity base sub 1 plus base sub 2. Then let us substitute the formula wherein the median is RS equals copy 1/2, then base sub 1 is TO, this one, and then EN is the second base. Then substitute 18 and 24 to our formula. So we have RS equals 1/2 of 18 plus 24. So add like sign, so we have to add 18 plus 24. So the answer is 42, and 42 divided by 2 or get the half of 42, and the answer is 21 units. So that is the value of our RS, which is 21, which is the median. Now let us proceed to example letter D. If TO equals 2x minus 5, RS equals 12, and EN equals 3x plus 10, find x. But do not forget, this 2x minus 5 is only representation of TO, and 3x plus 10 is the representation of EN. So we can solve also EN and TO, but before that, let us solve for x. Using the formula, median is equal to 1/2 of quantity base sub 1 plus base sub 2. Let us substitute this one, line segment RS as our median. Then the bases are line segment TO and line segment EN. So we have line segment RS equals 1/2 of quantity line segment TO plus line segment EN. Then let us substitute the representation of TO and the representation of EN, which is 3x plus 10. Then RS, which is 12. So now we have 12 equals 1/2 of quantity 2x minus 5 plus 3x plus 10. Then we have to combine like terms. So we have 2x and 3x. Then we have negative 5 and positive 10. Then of course, cross multiply. So we have 12 times 2 here. So we have 24 equals 5x because 2x plus 3x is equal to 5x, while negative 5 plus 10, this is unlike sign. So you will subtract. The answer is positive 5. because as you can see, the sign of 10 is positive. That is the biggest number. Then after that, we will transpose positive 5 on the left side of the equation. So it becomes negative 5. Then we have 24 minus 5 equals 5x. And then 24 minus 5 is 19. Then after this, we have the numerical coefficient by 5. So all you have to do is to divide the both side of the equation by 5. And then of course 19 divided by 5. And then we have 5x divided by 5. So the final answer is 3.8 units. So we have x equals 3.8 units. Then let us try to solve the value of TO here using 2x minus 5. So 2x minus 5, let us replace x with 3.8. So we have 2 times 3.8 minus 5. And then TO equals 7.6 minus 5 because 2 times 3.8 is 7.6. And then 7.6 minus 5 is 2.6 units. And then afterwards, let us continue by EN. So EN equals 3x plus 10. To get the length of EN, let us replace x by 3.8 units. So we have 3 times 3.8 plus 10. So 3 times 3.8 is equal to 11.14 plus 10. So the total is 21.4. Then add, check if your answer is correct. 2.6 plus 21.4. What will be the answer? Okay, the answer is 24. Then get the half of 24. Get the half of it. 24 divided by 2. What will be the answer? Okay, the answer is 12. We have 12, wherein this is the value of our median, which is 12. It means the value of your x is correct. Then let us continue. Example, letter E, if TO equals 25 and RS equals 28, find the N. So in this example, class, the unknown is one of the base, not the median. So the same formula, but as you can see, you have to substitute the RS here. So as you can see, this is the missing now. So nandito na siya sa kabila. So multiply 28 times 2. Of course, we have 56. And then copy 25 because 1 times 25 here is 25. Then 1 times EN is also EN. So we have here. Then again, you will transpose 25 to the left side of the equation. So it becomes negative. So EN 56 minus 25, and that is 31 units. Okay, so EN is equal to 31 units. And that's the end of our lesson, which is all about theorem number 6, the median of a trapezoid. Thank you and God bless.